Hello, friends. Welcome back. So, till now we have seen two things. One thing is like how we can tokenize using the count vectorizer, and the other one was tokenization based on the TF IDF, which means term frequency and inverse document frequency. So this one is used for assigning the significance to a word in a sentence, or you can say in a text, or you can say in a document. So this tokenization is based on the significance of a particular term or the terms. So we assign the significance labels to the words in the document to find out how significant this word is for deciding the you know for deciding the sentiment of this particular document, or for this particular text. But if someone asks you that we have assigned the significance of something like some value like 50% or 60% weightage to a particular term, but what is the probability that if this particular word has been used in a particular sentence, then how surely you can say that this word has been used in a negative sense, or in a positive sense, or in a neutral sense? So in that case, you need to understand that you need to take the help of the probability theory. For example, if someone says that there is a word free in the mails, right? If the word free is there in the mails, then what is the probability that this mail will be a spam mail, right? What is the probability that this particular mail is a spam mail when there is a word free in any of the mails? So it may not be that all these spam mails have, this word free. Maybe some of the mails are not spam. But if there are mails which are 70 to 80% are there, and they are containing the word free, and they are spam, right? From the training data, we see that 80% of the mails which contains the word free, they are spams. Then in that case, we can say that yes, this free word, if there is available in a mail, then in that case, that particular mail could be a kind of spam mail, right? So this is the concept which we are going to discuss today in the Bayes theorem. So this is a probability related theorem. So this is a conditional probability related theorem basically, and this theorem means in this theorem we are trying to find out what is the probability of some event to occur when some other event B has already occurred, right? So this is the similar thing, like this event A you can consider as a spam. You have to find out whether a mail is a spam when the event B has already occurred, which means that when the word free is there in your mail. I mean, this event has already occurred. I mean, you have got a mail with word free. This event has already occurred. And now you have to find out whether the mail is a spam or not. So you have to find out the probability of event A when the event B has already occurred, right? So you might have studied this Bayes theorem in your school days, in your college days, when you were studying probability, but you might not have thought of this, that where it could be used, right? So you might have seen some simple examples, but even after seeing those simple examples, you might not be able to connect like what is the significance in the real life, right? There are different examples of using the Bayes theorem. For example, if some person has headache, right, then what is the probability that he has some problem in the brain, right? Headache is event B, which has already occurred. You have to find out if he has some problem in the brain, maybe brain tumor or something. So you have to find out the probability A. So in the clinical studies in the medical field, this is also used, and this is used widely, right? So that is why you need to understand it very clearly, and I think you might be able to connect like what is the importance of the Bayes theorem while finding out these kind of things, or finding out these kind of analysis, to do this kind of analysis to find out whether a particular thing is spam or not, or in case of sentiment analysis, if some word is there in a particular text, then what is the probability that it has a you know it has a positive sentiment, or it has a negative sentiment, right? It may be that there is some word good in a mail, and if there is a word good in the mail, then It may be that this particular word has been used in a positive sense, right? But if there is something like not good, then in that case, maybe this word, maybe you forget about maybe. If it has been used like not good, then in that case, this particular male has a negative sense. It has a negative sentiment, right? So these kind of things are really important to find out the pattern, uh, whether a particular word used in in a particular sentence, in a particular mail or in a particular document, whether it leads to a negative sentiment or a positive sentiment or a neutral sentiment, right? So you have all this data with good, with not good, with bad, all these words. You have already the data, training data, which you prepare. Like there is a sentence with something not good, then in that case you give it a negative sentiment. So you are training your model that you need to see this, that this is not good written, then it means that even after being good word is there, this has a negative sentiment. So why it has a negative sentiment? Then in that case it will find out the phrase that yes, it is not good, right? It is the phrase not good which is there. Then in that case, it could be that it is used in a negative sentiment. So it will try to find out the pattern. It will try to find out the phrase, which also need to be looked upon to find out the sentiment of a particular text or a particular sentence. So this is where the conditional probability is applied, or you can say the Bayes theorem is applied. And Bayes theorem is really important in the medical field, in the clinical trials, right? In that area, in that case, in that studies as well, in those studies as well, this conditional probability is used, right? So these are the things. So let us understand the conditional probability, that how we can find out the probability of event B when the probability of event A when event B has already occurred, right? So let us see uh, the derivation of this Bayes theorem. So let us see how we derive it and what is the formula. See, when you talk about the probability, you need to take care of two things: sample space and event space. If you don't know what is the sample space and what is the event space, then you can go back to your college days. You can find out your old notes, and you can or you can find out some books from one of your kids, or maybe one of your friends, to find out like what is the meaning of sample space and what is the meaning of the event space. So sample space is basically the possibility of all the possible outcomes. All possible outcomes. You have to see that all possible outcomes are what, right? Like suppose you throw some dice, then in that case sample space will be 1, 2, 3, 4, 5, 6. Anything can come, right? So whatever can come when you throw a dice, all that set, that entire set makes the sample space. When you throw a dice, then in that case, it's like 1, 2, 3, 4, 5, 6. Anything can, anything can come, right? So this will be the sample space. But event space is something that you want to know. You want to occur, right? Suppose you want to occur, you want to find out the probability that an even number will occur. When you throw a dice, then in that case, even number should occur. Even number should come. So in that case, the event space will be 2, 4, and 6. So in the event space, there will be only 3 elements. And in the sample space, there are 6 elements, right? So when you derive the probability, then you give E upon S, event space upon sample space. So it becomes like 3 by 6, so 1 by 2. So this will be the probability of an even number to come when you throw a die, right? So this is how the basic probability is found, right? Now let us see about this conditional probability. For the conditional probability, let us see the event space and the sample space. Suppose this is my set A. Set A means all those events which can occur when we are talking about the event A, right? And event B is the set of all those events, all those possibilities. Basically, A and B are the possibilities right now. All those possibilities which can occur. So when we are talking about A to happen when B has already been done. We have to find out A to happen. What is the probability of A to happen when B has already done? Right? So what will be the sample space here? Whether it will be A, whether it will be B, what it will be, or it will be A union B. What will be the sample space? See, we have to find out the A to occur when B has already been done, which means that A is totally dependent upon B. So the sample space will be B. Neither A union B nor A. A cannot be there. I mean, you could have easily identified that A cannot be there, can never be there as a sample space. A union B, some few of you could have thought of, but yeah, it's only B which is the sample space. So sample space will be B. Now we have to find out the occurrence of A, right? Occurrence of A when B has already been done. So event space, what will be the what will be the set for the events when the B has already been occurred and you want to know whether A will occur or not. So in that case, it will be A union B or A intersection B. What it will be? I hope you might have guessed it right. If not, then let me tell you it's A intersection B. It will be A intersection B. So event space will be A intersection B. Okay. So now you have to find out the probability of A to occur when B has already been done. Right. So what will be the probability? P A when B has already been occurred, then it will be like P A intersection B divided by P B. Right. So for A to occur when B has already been occurred, it will be P and P A intersection B and P B divided by P B. Right. Because we have PS upon PE. Right. E upon S. Event space upon sample space. This is the formula. So our event space will be the probability of A intersection B, probability of this to occur upon probability of B to occur, right? So both you will use here and you will divide the PA intersection B by PB, right? So this will be the formula for independent event A, not independent, basically dependent event A when B has already occurred. Now let us see another thing. Let us do the other thing. P probability of B when A has already occurred. Then what will be the formula? You can understand easily. P B intersection A upon PA. Got it? You can see this. P B A B to occur when A has already occurred. It will be P B intersection A upon PA. Right? So now if you see, then you can see P from this this is formula 2, this is formula 1. Now from formula 1, let me give the name. It's 2, it's 1. So from 1, PA intersection B is equal to PA or B. I'm saying or, but it's like PA when B has done multiplied by PB. Now from the 2, P B intersection A is equal to P B to occur when A has already occurred into P A. This is formula number 3. This is formula number 4. Now you know from the set theory, you know from set theory, you know what you know. A intersection B is equal to B intersection A. It follows the commutative law, which means both the 3 and 4 are same. So which means P A to occur when B has already occurred into PB is equal to P B to occur when A has already occurred into P A. Now you can see the formula, the final formula, which is known as the Bayes theorem, as PA to occur when B has already occurred is equal to PB by A into PA divided by PB. This is the final formula, which is known as the Bayes theorem. Right? So this is how you can derive the Bayes theorem, and this is the Bayes theorem. And we will use this Bayes theorem to understand that how you can find out the probability of a word or a sentiment to be positive, negative, or neutral when all these things are known. Okay? So let us see in the next video that how it is used to find out the sentiments. We will see a simple example, and then we will see that how in the sentiment analysis it is used. Okay, so till then, have a nice day and bye bye. And I hope you might have understood it clearly today. And in the next video, we'll meet again. Till then, have a nice day and bye bye. Please share my videos, like, and subscribe my channel. Thank you.